Welcome to The Explainer. Today, we are getting right into the core of the Cisco ACI fabric. We're talking about the APIC cluster. Now, this isn't just another component. It is literally the brain of your entire network. And trust me, understanding how to keep this brain healthy is an absolute must for anyone in the networking world. So think about that for a second. The APIC cluster is the control center, the single source of truth that's running the whole show. So what happens when that brain isn't, well, at 100%? Things can get pretty interesting, and not in a good way. Okay, let's dive in. All right, here's our game plan. We're going to start with the basics, the architecture of the APIC itself. Then we'll get into what happens when things go wrong, and they do go wrong, from a single controller going down to that dreaded split brain scenario. And we'll finish up by getting you hands-on with the command line tools you need to troubleshoot like a pro. So how in the world does this APIC cluster manage a potentially massive network and do it with both speed and, serious reliability? Well, the secret sauce is a really powerful database technology called sharding. Let's break that down. Okay, so instead of having one gigantic, monolithic database, which would be a single point of failure and super slow, the APIC cluster is way smarter. It uses this thing called sharding to break all that data into smaller, much more manageable chunks. Think of it like this. Trying to find one book in a massive library with no organization would be a nightmare, right? Sharding is like organizing that library into sections, fiction, nonfiction, whatever, making it way faster and more efficient to get what you need. The real genius behind the system's resilience comes down to these three simple steps: partition it, replicate it, and distribute it. Every single piece of your configuration data gets copied 3 times. And this is the crucial part. Those copies are spread out across the different controllers in the cluster. What does that mean for you? It means even if you lose an entire controller, your data is safe. Your network stays up. No single piece of hardware failing can cause data loss. Okay, so with all this data spread out and replicated across multiple controllers, how do you actually know if everything is in sync and working correctly? Well, the APIC cluster has a very specific term for a perfectly healthy state, and it's one you're going to want to burn into your memory. This is what you always want to see in your APIC graphical interface. Fully fit. That's the gold standard. It means all your controllers are healthy, they're talking to each other perfectly, and their databases are completely synchronized. It's the big green light you're looking for before you even think about making any changes. Now, on the other hand, if you see a status like, say, data layer partially diverged, that is a major red flag. Seriously. It's like a giant stop sign for your network. You stop everything. No new policies, no deploying new applications. Your one and only priority at that point is to figure out what's wrong and get that cluster back to a fully fit state. All right, let's get into the nitty-gritty. What actually happens when a controller just goes offline? Well, the impact really depends on the size of your cluster. And this is where design choices become super important. Just look at this table. It tells a really important story. A single APIC? Yeah, that offers you 0 fault tolerance. With 2, you get some protection. The fabric goes read-only if one fails. But the magic number, the one that gives you true resilience, is 3. A 3-node cluster lets you lose a whole controller and still have full read and write access to your fabric. And that's all thanks to a concept called quorum. So for most real-world deployments, a 3 APIC setup is pretty much the standard. But you have to be aware of the risk. If you lose 2 of those controllers, your entire fabric gets frozen in place. It becomes read-only. That means no new apps, no policy changes, no modifications whatsoever until you can get at least one of those APICs back online and regain that write access. This is exactly why monitoring your APIC health is so incredibly critical. Now let's talk about a scenario that can give network administrators nightmares: the split brain. This is when all your controllers are actually up and healthy, but for some reason, they can't talk to each other. And here's why that's such a big deal. Just picture this. You've got a multi-pod setup with APICs in 2 different data centers. If that WAN link between them goes down, you suddenly have 2 isolated groups of controllers. Each group looks around, can't see the other guys, and thinks they've failed. That's where the trouble really starts, because both sides might try to take control of the fabric. So to stop a split brain from completely corrupting your database, the system does something pretty smart. It elects a majority. In our 3-node example, the site with 2 APICs gets to stay in read/write mode. The lone APIC on the other side, it automatically switches itself to read-only. It's a crucial safety net that prevents you from making conflicting changes on both sides at the same time. And here is a super critical piece of advice from the source material. even if that majority side is technically in read-write mode. You should treat the entire fabric as if it's in a maintenance window. Don't make changes. Your number one priority has to be fixing the underlying connectivity problem and healing the cluster. Get everyone talking again before you do anything else. Look, failures are gonna happen. It's just a fact of life in IT. But you can absolutely prepare for them. And a standby APIC is one of the best ways to do that. It's a key piece of a resilient network design, and it can make your recovery process a whole lot smoother.
Think of a standby APIC as an insurance policy for your network's brain. It's a fully configured hot spare, just sitting there, staying up to date, ready to go at a moment's notice. If an active controller fails, you can just promote the standby to take its place. This can dramatically reduce your downtime and makes the whole replacement process so much easier.
Okay, the graphical interface is great for a high-level overview, but when you really need to roll up your sleeves and get your hands dirty, the command line interface is your absolute best friend. It's a powerful tool that's going to help you diagnose and solve even the toughest cluster problems. If you remember only one command from this entire explainer, please make it this one, cluster_health. This single command is your go-to. It runs a whole series of tests and gives you a really comprehensive health check on everything from basic connectivity to the nitty-gritty details of database synchronization.
So when you run Cluster Health, you're really focusing on these three key areas. First, the overall fully fit status. Then you dig into shard convergence and leadership degradation. Now, if you see failures in those last two, and all your APICs are online and talking to each other, that's a really good sign that it's time to call in the experts at Cisco TAC for a deeper look.
So in the end, the APIC cluster's incredible resilience isn't magic. It's just the result of some really brilliant distributed architecture. Now that you understand these core concepts, sharding, replication, and quorums, you have the power and the knowledge to keep your network's brain healthy, robust, and ready for pretty much anything.